I chose to do the strategy pattern for my task 3 in this week's assignment. And like just the basics for what a strategy pattern is and what it's good for. Well, it helps getting rid of complex if-else statements for algorithms. It does this by using an interface class that holds the algorithm that is then inherited by subclasses. These subclasses give the algorithm its uniqueness. So in theory, each subclass that would inherit this abstract interface class would basically have its own take on this algorithm, and depending on which object of that subclass you called, the algorithm would act differently depending on, again, which one you called. So that is kind of the gist of what a strategy pattern does and how it's helpful. It also helps to kind of just isolate things. So again, if you don't have this type of mentality, you might end up with a really big algorithm with a whole bunch of if-else statements and really complex and very wordy when it comes to the actual algorithm. Whereas in the case of using a strategy pattern, you kind of isolate that out and make things a little bit more bite-sized and a little bit easier to read. So here I've got on the screen basically the general concept for the strategy pattern itself. As you can see, this is the abstract interface class right here, and then depending on how many different subclasses you have, in this picture it's only showing 2, but you could have in theory as many as you wanted to that have its own take on the algorithm that you're trying to implement. Then of course you're going to have a client class that calls this. So again, that is kind of the general concept for the strategy pattern. For my specific implementation of this, I decided to do I decided to go off the gym scenario that we've been talking about in class, and then what I did for this is I basically made a algorithm for creating a monthly fee for different members. So in my example I'm about to show you, I have 3 different types of members that could be in my gym. I've got a silver member, I've got gold members, and I've got VIP members. Depending on which tier the customer is in, they'll get a discount off the monthly rate. So whenever we call this basically monthly rate method, depending on what the customer object is, whether it's the silver member or a gold member or a VIP member, their rate will show differently just off of the actual object that they are, because the algorithms are divided into these subclasses. So here is my program in Asta. Basically, here are my subclasses. Here's all 3 of my different members, all using the same method that they inherit from this abstract interface class up here, pricing base. And then of course I've got a main method which is going to call the pricing base, and depending on which again member they are, the price will change depending on again which member they are. So that's kind of the gist of what I've done. If we look at my actual implementation, here is my main class. We can see if we run this, down here I've got a little system out.print that says silver members should only pay $95 a month, my gold members pay a little bit less, and then my VIP members pay the least. This is based off of, just to make the math simple, I made the monthly fee for the gym. I know it's kind of crazy, but not $100 a month, so we can kind of see the easy math here. My silver members get a 5% discount, whereas my gold members get a 15%, and then my VIPs get a 25% discount on the monthly rates. And that's kind of where the math that you're seeing down here lines up with. You can see that I'm creating 3 different members in my main. I've got a new silver member, I've got a new gold member, and then I've got a new VIP member. I'm passing the monthly rate into my generate price method, which then goes to over here these different classes. So for example, here's my silver member. You can see that their discount is 5% off of the rate that I pass in, which again is what I'm calling the monthly rate. In this example, it's $100 a month. If we tab over to VIP member real quick, you can see it's 25% off So that's kind of what we're doing here. And this is a really simple, basically straightforward implementation of the strategy pattern. And yep, that's it. Thank you.